Hello friends and welcome at my channel. Today I would like to bring you the last limit of trigonometrical function in this playlist, so far considering x towards 0, something with sine, cosine, double angle and so on. I think we've done enough and this is going to be really the last one so far. Maybe if I would like to add one more later on, I'll do it, but for the moment it's going to be it. Alright, so let us see what we're computing. We are computing the limit. X is approaching 0. We're having 1 minus cosine of x times the square root out of cosine of 2x, and we're also dividing it by x squared. Well, I was too generous with my root sign here. Let's put it a bit just more modest. Why? Well, because we're immediately multiplying times 1, which we are rewriting as 1 plus cosine of x times the square root out of cosine of 2x, and divided by exactly the same value, as you can see it right here. So what we're going to get is the limit x towards 0, and now you see we have one of the binomial formulas in the numerator, so we're having 1 minus cosine squared of x times, well, if we square the square root, it's going to be just cosine of 2x divided over x squared times 1 plus cosine of x times square root out of cosine of 2x. And as you can see, we have no trouble at all with cosine values to become to let the x value to run against 0 for the cosine values, because every time the cosine of 0 is being considered, we are having 1, which is absolutely fine. In the denominator we have to do something about x squared. Alright, and this kind of set of exercises or questions was all about finding or applying sine of x divided by x as x is approaching 0. So let us see what's happening. We're having here a limit x towards 0. Let's keep 1 the way it is. Cosine squared is actually 1 minus sine squared of x. And hope that you remember, I just remind you, the cosine of 2x is basically cosine squared of x minus sine squared of x, as we've seen in the previous videos. I'll link it here, one of the videos as well. And so we just rewrite it this way: cosine squared of x minus sine squared of x, we got it, divided over x squared times 1 plus cosine of x times the square root out of cosine of 2x. I hope I'm not doing any kind of mistakes. What I'm multiplying here, wait a second. I'm multiplying cosine times the square root, and then that's the story, right? Okay, that seems to be fine. Okay, so if we now multiply it out in the numerator, what are we going to get? Well, we're getting 1 minus, then you see 1 times cosine squared is just giving me cosine squared of x. Then we're having minus sine squared of x times cosine squared of x, plus, is that correct? No, it's not. So cosine squared is fine, that's why now minus sine squared of x, yeah. And we are having plus sine to the power of 4 of x, close the parentheses, divided over x squared times 1 plus cosine of x times square root out of cosine of 2x. So basically we kind of need everything we've done previously in the playlist, which is nice to apply. Alright, so can we simplify it somehow? Well, not quite, right? Because we're multiplying here, we're adding here, blah, blah, blah. So 1 can be written once again as cosine squared of x plus sine squared of x. Then we have minus cosine squared of x. Then we have plus sine squared of x, cosine squared of x. Then we're getting plus sine squared of x, and then we're getting minus sine to the power of 4 of x, and we divide it all by x squared times 1 plus cosine of x times square root out of cosine of 2x. So what can we simplify here? Well, these two are gone, and these two are not gone, but they can be added, right? So we are getting here a limit x towards 0 to sine squared of x in the numerator. Now we still have sine squared instead of cosine squared, so let's write it sine squared of x. Instead of cosine squared, we're just writing 1 more 1 minus sine squared of x. Alright, let's shift my picture away. And then we're still having minus sine to the power of 4 of x. We're dividing all that stuff by x squared times 1 plus cosine of x times square root out of cosine of 2x. Nothing special about the colors. Sometimes I decided to make it, you know, life more colorful. Alright. So what is happening here? Well, are we on the right path? Seems to be right. Because you see, the more signs we have, the more cosines in the denominators, the more sines in numerators, and the more x squares that we can kind of combine with sine squares. It seems to be right. That will be. Okay, so we're multiplying it out again. So we're having, or we can even skip one step. You see, sine squared of x is given here, here, and also there. It's all presented. So we're kicking sine squared of x outside of the parentheses. What would we get? From this on, we would have only 2 remaining, plus this one is gone, so the parentheses are remaining, 1 minus sine squared of x. And from sine to the power of 4, we have sine squared of x remaining as well. And we're dividing it by x squared times 1 plus cosine of x times square root of cosine of 2x. And we close the parentheses. And now you see it's nice because now we can separate this limit. We can write it as the limit x towards 0. We're just having sine squared of x divided by 8x squared times the limit x towards 0. This is 3 minus 2 sine squared of x divided over 1 plus cosine of x times square root out of cosine of 2x. And now we easily can compute it. This is doubled 1. Sine of x divided by x times sine of x divided by x. As x is approaching 0, this is 1 times 1, which is 1. This one is approaching 0. This one is approaching 1. This one is approaching 1 as well. So 1 plus 1 is going to be 2. And we are getting to 3 divided by 2. This is the result of this limit. Thanks for watching, guys. See you in the next videos that are not going to be we're not going to be computing any kind of trigonometrical limits anymore of this kind, but there are so many interesting different topics we're gonna consider soon. So stay tuned. All the best. Bye bye.